You guys are quick to get in. Love it. Fantastic. So I'm going to drop a link for us all. If you wouldn't mind just going into this link real quick. We're not going to quite do anything with it yet, but just go ahead and grab that. It's in the iOSPT7 channel. And then from then on, I'll probably start using that iOSPT7 notepad channel to share code. So go ahead and share my screen here. So I'm just going to pull up Training Kit and just kind of review what we're going to go over specifically today, so we can kind of have that in mind. So we're going over the Swift fundamentals in general this entire sprint here for the next 2 weeks. And today we're going to be talking about some basic data types, ints, doubles, bools, strings that kind of are the basis for everything that we end up using just kind of on their own. And then we can get into how we can kind of combine those things, to make them a little bit more suitable to our needs later on in this sprint. We'll be talking about mutability, so what let versus var means, kind of those keywords there. Talking about using some conditional logic, and this is going to be sort of a continual topic that we go through again multiple times this week as well. We'll talk about if statements today, and then we'll get into other ones in a couple days here. And we'll also be talking about switch statements as well today. We'll be talking about how to iterate over arrays. So performing, one chunk of code that we write to a bunch of things at the same time or kind of in succession so that we don't have to do it over and over and over again and kind of repeat ourselves. Talking about how to make functions, why we make functions at all, what the point of those are, and then kind of just talking about these curly braces here and kind of how that groups blocks of code together. So that's going to be kind of what we talk about today. We'll also be talking about tuples. So that's kind of our overall goal today. So let me just go ahead and I'm going to pull up this link that I just sent to you. It's a GitHub repository, and we're going to be talking about Git and GitHub next Thursday, or sorry, this Thursday, the next time that we have a guided project. But for now, all I want you to do is, this has a starter playground that we're going to use in Xcode. So if you will just go to that link and click this clone or download button, and then you may not have 3 options here, but there should be this download zip. So if you go ahead and grab that, that will download a zip file to your computer. And if I pull up my very messy downloads folder, it'll look something like this. You may have something that is either, Safari can kind of unzip things for you. So this may be a folder, or you may have this .zip. If you have the .zip like I have, all you need to do is just double click it to unzip it. And then you'll get the kind of the unzipped entire folder here. Does anyone need me to show that again? Okay. I'm gonna throw in a link to our Slido while I'm thinking about it here. So give me 1 minute. Okay. If you have any questions, you can throw them either in the Slido, or again, you can just kind of unmute yourself and ask verbally if you prefer. Okay, so once you've got that open, all you'll need to do is you can just double click this swiftfund1.playground, and it should pull up Xcode for you. Mine is not pulling up the right one. Or is it just not? My Xcode's not been behaving. I've been having to use a different version of Xcode. Sorry, give me 1 second here. So it may ask you if you want to, like it'll say, this is a file downloaded from the internet. Do you want to open it? Just go ahead and click open. All right. So we're going to get into using like Xcode projects and building full iOS apps in a couple weeks from now. But to start out with, these playgrounds are really great because they're a very quick way to just get some code written down quickly, and you can kind of just run code without having to build an entire app around it. So it ends up being kind of a really nice way to do this. So if your code looks like this, these are actually formatted to be kind of a little bit more as instructions. So what you can do is you can kind of make it look a little bit nicer. If you want to, you can go up to Editor in this Xcode window. And then down here at the very bottom, once you click on Editor, it'll say Show Rendered Markup. And then that will kind of put it into like actual white text that's a little bit easier to look at, or black text if you're on a white background. So if I do that, it makes it a little bit easier to read. If you look in, if you'll real quick go over to Zoom, you should see this little, if you click on the participants icon, it's like two little icons of people. You should at the very bottom see this little window here, or these kind of buttons. Sometimes I'll just use this to kind of gauge where everyone's at, see if I need to go over anything again. So will you give me a yes right now? Just give me that little yes check mark if you have this this file open, so I know we can kind of go on and we're all caught up. And if anyone needs help, please feel free to unmute yourself and we can get it sorted out here.
Sorry, so where do I click again? From Zoom?
For this, it's in the little participants. If you see that little icon of like two people, that looks like it has a 25 next to it. And then at the very bottom, it's going to have the little yes icon.
Oh, I see. All right, thanks.
Yep, no worries. Sorry, I wish I could pull my Zoom window over, but Zoom hides it. So I had to like take a screenshot here in order to kind of show what it looks like. Okay, I've got a couple people missing. Does anyone need help getting this this playground open? Okay, all right, I'm gonna move on then. So like it says here, as tradition dictates, we need to start our kind of exploration of Swift with a hello world statement. That's just kind of a tradition here. So we're gonna just say let hello string equal, and we're gonna put in quotations hello world. So just real quick, because I had a student ask about this in my morning class when we did this lesson. Don't worry about your, like, if I'm on like line 5 and you write this on your line 3 or something, it doesn't matter. The lines are nice to kind of show where I'm at, but we could have different spacing. So it's no worries if you don't necessarily put that code on the exact same line. It should work all the same if we're kind of following the same order. Not necessarily putting them exactly on the same line though. So let's kind of actually look at this. If you've programmed before, or if you've done a little bit of Swift before, this may look a little bit simple, but there's kind of a lot going on here. So let's kind of break it down. We've really got 4 parts. We've got this let, we've got this hello string, whoops, the equal sign here, and then this hello world. So these are all kind of 4 individual parts of a single line of code that are kind of doing a lot here. So let's explore what each of these things mean. Can anyone give me an explanation of what let means here.
Okay.
Okay, go for it.
So I believe let is a constant, which means that further along in the application, it's something that you can't change.
Yeah, exactly. So this is a constant, constant value, meaning I cannot change this. So the value cannot change after it has been set. Perfect, thank you. So then what would be the sort of opposite end of this coin for if I have something that I can never change? What would be the thing that I could always change its value for?
Variable.
Variable.
Yeah, variable, perfect. So we would do the var keyword there. This is a variable value. Value can change as many times as we want. So that's kind of our first option here. We could say, yeah, we want this to be a var, or we want it to be a let. It's kind of up to us. But when we're making a property, then that's kind of our first option, is we decide, do we want this to be a let or a var? And depending on kind of what it is, we just kind of have to make that assumption here. Does anyone know what this thing is called here? Any idea? If not, that's cool. Some languages tend to call it something different.
It's the what's that word?
Is it a value?
It's not the value.
It's
A
the
container.
descriptive term. The it describes what the value is. And I cannot think.
Label.
You could maybe call it a label. I heard someone say
Yes,
container.
there you go. Label.
It would also sometimes be referred to as like an identifier. I would probably say, like, you could even just call it like the name of your constant or variable, but probably the more kind of realistic term for it would be like identifier, or maybe container, label, etc. So we'll kind of refer to it as the identifier for now, but there tend to be quite a few names for this. So this is just a, I'm just going to say a, not a word, but a set of, well, a way of describing what your value is. So for example, hello string, that kind of says to me, oh, okay, that's probably something to do with hello, in this case, hello world. And then I also know that this is a string, not that you always have to put string there, but it's something descriptive. What we're trying to do here is in Swift and in iOS in general, whether you're using Swift or Objective-C, we tend to place a lot of value on naming our properties like these or our functions in a way that describes what it is, so that when you look at this code, it's very readable. We're actually able to say, oh, I can kind of look at this and just decipher what this means. You may have seen other languages where it's like, you know, var a, or whoops, var a, or I was actually just reviewing some code earlier today that was like, their variables were like a, then b, then C, then they went down to J and K, and it was like I had to sit there and think about what everything meant. But if I have a really good identifier or a name for my constant here, then it just sort of falls into place, and I can naturally read the code and understand what it is. So we tend to have some kind of more descriptive naming conventions than maybe some other languages. Any questions about what we've talked about so far here before we move on to this kind of second half here? Okay, so what about this equal sign here? What is that doing?
Assigning a value.
Assigning a value. Yep, this is, you could call this the assignment operator. So we're going to say the value of my identifier is going to be, and then that's, whoops, shoot, I just got rid of that, sorry. is this hello world here. And that's saying, hey, I'm going to store this string of text here inside of this hello string. And the way that I'll reference this is just by using hello string. So imagine if, it's not a ton of work to type this out, but maybe I had, a ton of text here. Don't do this, but, say I had like a paragraph's worth of text. Well, it would be a pain to reference that string by what the text is all over and over again, where I could just kind of put that inside this identifier and assign the value to this. So I could say, whenever I want to print that out or show it to the user, I could just refer to it as hello string. And that's kind of the whole point of these identifiers holding some value that you assign to it. Do we feel okay with that? Are there any questions on that? Oh, sorry, Ben.
It's all good. Quick question about the identifier. Is there any type of like characters or anything that we're not allowed to put in the identifier?
Yes. So I actually think I'm getting a little bit ahead of myself. I am. That's okay. The first character has to be either a capital or lowercase letter or an underscore, and then you can have numbers. If you try to make a variable or constant with number first, and then you say like in string or something, it doesn't work, but you could do like string 9, and that's totally cool. So those are the limitations. In theory, you could actually, emojis are actually valid. So in theory, you could do something like that. Not that I generally see that outside of like, just kind of for fun code, but generally we follow something that's called camel case, and I'm glad you brought that up, where as far as these properties go, these variables or constants, we start with a lowercase letter, and then if you have multiple words that you're trying to do, you can't have spaces in here. The compiler gets a little bit confused there. So what we do to separate words is every subsequent word has a lowercase letter. Other languages use what's called snake case, where they would do something like this instead. And that's actually valid in Swift, although not necessarily the naming convention we tend to follow. So does that answer your question, Ben?
Yeah, perfect. Thank you.
Awesome. Okay. All right. Any questions before we move on? All right, killer. This is more of kind of just a look at what actually I was already doing before. These comments, you can make them in two ways. You can either use the double / to just make a single line comment, or you can, you can either do that or just do a / and an asterisk after it to have a multi-line comment, and that becomes a comment until you end it with an asterisk and then a /. So you can kind of choose which one you want to do. This one, they've got asterisks on every line, just kind of to keep things in line more or less, but you don't have to have those. It's just really the ones on the end and the start that matter. So if you see me do comments, generally they're things that I'm going to write out to help you. Comments are great for your own sanity and just making sure that you know what's going on. As we kind of go on, you'll probably use less and less comments, but I tend to write them out quite a bit just so you can kind of know, what a specific chunk of code is doing. And I tend to, if I think a comment is kind of worth saving for you, I'll throw it into that iOSPT7 notepad channel. So you don't have to furiously write down what I'm writing down. I'll just copy and paste it over to you. And if you're ever like, hey, can you give me that specific comment, and I don't give it to you, let me know, and I'll definitely throw it in. So on that note, let me grab these, and I'll throw it in there so you can have that. Let's see, did everyone get added to that? No. Okay, I just kind of put a link to that notepad channel in the PT7 channel, so you can join that if you're not already in there. All right, so let's move on to our identifiers here. We kind of already did that, so let's actually, I kind of went a little bit overboard there, and I already did that. So let's let's just write something here so we have something that we can reference when you're taking a look at this later. So let's maybe just do like my name, for example. And again, we're going to follow that that camel case where the my is lowercase and then the name is the first letter is uppercase. Whoops. So go ahead and throw your name in there. And when we make these quotation marks, we're specifically saying we're making a string, or just essentially a string of characters, either a single character or actually nothing. You can just have no characters at all. Or in theory, you could have an entire book's worth of text in a single string. Not you probably want to do that, but you could. So let's take a look here. There's something called print, which can be a very useful thing, which gives us, like it says here, it writes the textual representations of whatever you give to this function into what's called this standard output, and this ends up being this little thing down here. You can just kind of drag this little bottom bar up and down. The playgrounds do have a little bit of an added benefit that a normal Xcode project doesn't have, where if you either click this little play button right here on the left, or you click the play button down here at kind of really the bottom left, it'll actually show you kind of the result here without you having to actually print anything. So we won't print too much here. I'm just going to print my name just to show you, and then I'm going to comment this out so it's not kind of cluttering this up, because we'll end up using the console in a few minutes here for things that you can't quite put all on over here. So again, just kind of to reiterate, these constants or variables, these properties that you make identifiers for, they'll start with either a lowercase or an uppercase character or an underscore, depending on kind of what you're trying to do. And then you can add any numbers you want after that. Any questions? Oh, sorry, Craig, I just saw that you had your hand raised. Do you have a question?
Are we turning in the guided project, so we should be like following you along and just typing it out?
So you're not turning it in per se, but you should follow along with me. So like you should be, I mean, I promise you're going to get more out of it if you do follow along and actually have your hands on the keyboard rather than just kind of passively listen, if that makes sense.
Mhm.
So, good question. Thank you for bringing that up. All right, let's go down to mutability. And again, I already jumped the gun on this, so I'm going to kind of blaze through this just a little bit. So we could say maybe we have like a number of staff. In this case, we have 6 of us. So we have Ayana and myself, then Hector is the SL, and then we have 3 TLs here. And then we have students, and I'm just going to put, we had about, I'll say 20. I'm not quite sure how many we actually end up having now. We can do something really cool that Xcode gives us, which is if you hold the Option or Alt key, your cursor turns from kind of either being the little text cursor or an arrow into these crosshairs, or if you hover over one of these identifiers for your constants, it will turn into a little question mark. This is a really cool thing to see kind of what something is. So if we click on this while holding Option for like staff, for example, it gives us this declaration. Depending on what you option click on, it can give you a little bit more information. But what this actually tells us is this is an integer, and we'll kind of talk about how that ends up working in a second. But what this is saying is I just made a constant called staff, that's its identifier. Its value is 6, and this number here is specifically an integer. So does anyone know the difference between like an integer and maybe a float, for example?
An integer is a whole number, and a float is something with like a remainder or decimal point.
Yeah, perfect, exactly.
And it's also a double, yeah.
Yeah, and then we've got like doubles, and we have a whole bunch of different numbers here. So it was actually kind of able to guess that, so we'll be talking about that in a minute here. But since these are numbers, we could actually do something like this. So we could maybe say iOSPT7 total. And then we could say it's our staff plus our students and just do a little bit of math here. And if I were to run this code, it would say I've got 26 people in here. So let's talk about variables. We've only made constants up to this point, but maybe we say, well, maybe I have a bunch of apples. So we could say like apple count is maybe 10. And then I'm going to say maybe I go to the store and I buy more apples. So I'll say like apple count is now 15 or something. So in doing this, nothing is wrong with that, even though I set the value here to 10, and then on the next line, I change this value to 15. It's like, oh, okay, cool, the value is now 15. Whereas, and you can just watch me here, if I said staff now equals 7, it would explicitly yell at me, and it would say, you can't do that, staff is a let constant. And so it would, if you click on this, it will give you an option and say, you could do this if you wanted to and make it a variable, depending on kind of what you're trying to do. That might be an option. But that's, again, that limitation of the let versus var here, constants and variables. Just like we did a little bit of math here with this iOSPT7 total, we can do a little bit of math on our apple count to just say, hey, maybe I eat an apple, so I want to -1 from my apple count. Does anyone know how we could just subtract 1 from whatever the apple count is currently? So whether it's 15 or 50 or whatever.
Isn't it like minus equals?
Yeah, so we've got a couple options. That's definitely the one that I would say is kind of the nicest, cleanest way to do it for sure. So -=1. That's kind of a nice shortcut. Anyone know another way we could do this?
Can you repeat the question? I'm sorry.
Yeah, no, you're good. So if I was like eating an apple and I wanted to subtract 1 apple from whatever my apple count was, how could I figure that out? I said like if I gave you a box of apples and I said, hey, I want there to be 1 less apple in there, and I want to know what that kind of total is after the fact. How would you know how many? I don't know if that quite works.
Are you asking if like to index it?
No, not quite. So if I, like, for example, if I wanted to say, right now the apple count is 15, so you could say something like 14, but if you maybe didn't know what the count was, what you could do is you could say equals the apple count itself, just -1 there, that way, if that makes sense. I think definitely the easier way of doing it is this, and that's ultimately what this -=1 does, is just do exactly what we've got here. It's just a kind of shorter form way of doing it, but that's really all it's saying. It's just saying the apple count is now whatever the apple count is currently, and then we'll just subtract 1 off of that. Does that make sense? Any questions on that? Okay. So let's talk about how it knew that this was an integer, for example. So we'll get into type inference now. And this is a really cool feature of Swift that not every language has. And I think we're like really lucky to have it, because it's a great way of just sort of saving yourself some time here. So let's write this out. I'm going to say let iOS equal, I'm going to put like Apple's mobile operating system. So I'm going to read a little bit of this paragraph here. So, well, I'll start up here. It says, all containers, or these identifiers, like we've talked about, these properties, in Swift must have a type set on them. So meaning when you make a constant or a variable, it has to know, is this going to be an integer? Is it going to be a string, a bool, float, etc.? And once that's set, it can't change. It's kind of, it basically, it can't change. This is what's called being a strongly typed language, whereas other languages like JavaScript, for example, you can change the type after the fact. Swift doesn't let you do that. And in my opinion, I think it's a good thing. So what it's doing here, this is called type inference, like it's saying. It says, meaning the kind of object stored in the container, or in this case, our string here, it was determined by looking at what value was assigned and just guessing like, oh, if you're giving me a value of type string, then the container's type should probably be a string to match that. And it's just doing a little bit of guessing for us, where we don't have to explicitly say, hey, iOS, you as a constant are now going to be a string. It just is able to kind of look ahead and be like, oh yeah, okay, you're giving me a string, I'll make myself a string, or be able to hold that string here. So, and that's exactly kind of what we see if I option click here. It says let iOS : string. So if we wanted to do this ourselves, and there are definitely times where we have to take over and just explicitly tell a container or an identifier here what its type should be. So we could maybe do something like this if we kind of jump down to this next little section here. Not that it really matters where we put this, but it's kind of related to this paragraph here. We could say something like, maybe we're setting the price for our like an iPhone, maybe like the new iPhone SE that came out a couple weeks ago. So we could say let price, and then I'm going to put a colon here and put that I want this to be a double. And what I'm doing is with this colon, I'm saying this constant called price is of the type double, or I'm kind of just setting that type explicitly as opposed to it just doing that type inference and kind of guessing for me. The type guessing doesn't always work. It will try to guess something, but it doesn't always get it right. I'll show you again. Excuse me. I'll show you an example of that in just a second here. So if we did like 399.99 or something, that would be like a valid double here. So we could, do math or anything that we wanted on that. There are a bunch of different number types. You'll get into them more when we start getting into iOS, and there are kind of some more specific ones when you start dealing with iOS, like graphics engine and all of that stuff that we'll get into. But for now, we really kind of have two main choices, which are doubles and floats. If you're curious, I can send you a link on kind of the explanation, what a double is and what a float is, but it just has to do with the largest number that it can hold in memory. So let's do this. If we do float here instead of double, then this would be a perfect time to say, I need to take over. If I know, I'm just going to put a comment here, I need price to be a float, for whatever reason that I can, I mean, this is a little bit contrived. If we were to do type inference here, watch what happens, and you can just watch me here. I want you to keep it as we have it here with float, but if I get rid of this and I option click on price, it's actually going to default to a double. And that's where I say this guessing will sometimes work, but for like floating point numbers, it just tends to default to using double. So there are times that you kind of need to take over and say, no, I actually want it to be this type. It's not very often, but it's definitely something to be aware of. And so we're going to kind of give it that explicit type. Now when I option click, it says, yep, I'm a float, and we know we're good to go. Okay, at this point, what questions do you have about anything that we've gone over? Or really any questions at all?
So you said a float and a double is the amount of like you said it's the difference is like the amount of numbers they can store.
Yeah.
Or so that the amount of numbers, so a bigger number, or how many decimal places they can store?
Probably both, actually. I think the precision goes both ways.
Okay.
It definitely goes up, but I believe it also goes down to how many decimal points you could also have, because that's going to take up an amount of space as well. So, and again, I can send you an article, or I think there's just like a Wikipedia page that kind of shows all of the different max and minimum numbers that you can go down to.
Can I just run a scenario by you, make sure I understand this correctly?
Yeah,
So
absolutely.
let's say price just so happens to be $400 even.
Yeah.
So that's going to read it as an integer. However, later on, we're going to math that price with tax or whatever, where the result could be a decimal. Then we would want to make this a double or a float.
Yeah, we could get around that with two ways. We could just kind of explicitly say, if we did like 400 here, then it would just know, oh yeah, okay, you're a float. And again, use that kind of explicit typing. Or actually kind of the next thing that we talk about, we could kind of go with your scenario, because that's actually a perfect kind of way of looking at it. And we could say, well, maybe I have a float and then I have an integer. So if I want to, or like a float and a double or something. So if you want to do some math, we need to do a little bit of conversion. So we'll go ahead and take a look at that next here. Is that cool if I just kind of put you on pause for just a couple minutes?
Yeah, man. Thank you.
Okay. Yeah, we'll definitely go over it. Any other questions?
Yeah, when's the best use case for a double versus a float? Like if there just comes a time you have to choose and you're like, all right, I want to make the optimal decision. Like when does that usually pop up?
At this point, just do a double.
Yeah.
Basically, a double is twice the size of a float. That's why it's called a double. But at the point that we're at now with iOS, it's such a small amount of memory that you just don't even have to worry about it unless you're
Yeah.
getting really, really nitpicky with your memory. But like, we're dealing with phones that have multiple gigabytes of memory. It's not like this is the iPhone 1 that had like 64 megabytes total or something like that. So
Yeah.
memory usage in relation to whether this is a double or float is a little bit irrelevant, and that's why it tends to default to being a double, just because you get a little bit larger capacity without there really being much of a trade-off at all. So great question. All right, guys, let's go ahead and take a break. I try to do breaks every 40 minutes, so we'll have 2 of them during the guided project, so we're not getting fried. So go ahead and get up, walk around, go to the bathroom, get a drink or anything you need to do, grab a snack, and we'll come back and we'll talk about fire safety. So I'll see you all in 5 minutes. You're welcome to just turn off your camera. You don't need to leave it on during the break or anything. So. All right, welcome back, everyone. So I just saw the question in Slido. Doing all this on one monitor is very hard. Any tips on managing all these windows? Uh, yes, sort of. If you are on a MacBook, something you can do is jump into your system preferences and go to displays, and you should see something like this, where you can say, you could potentially increase the resolution so you are able to fit more on the screen at once. That would be one thing if you just have a single screen. If you have an iPad, you could, well, depending on your Mac, you may have access to Sidecar, and that will kind of wirelessly give you another screen on your Mac. There are also other apps that will let you do it, like Duet Display is one. I can't remember how much this is. I think it's $15 or $20. But then you're able to kind of extend your screen that way, again, with an iPad. You can find some fairly cheap, sorry, not cheap, inexpensive monitors just on either Amazon, or if you have like a Craigslist, like you could find probably like a 21, 23-inch monitor for fairly cheap. And as long as it has like an HDMI port, you're probably good to go on that. You might have to have a dongle if you have a newer MacBook that has a USB-C port only. But I would definitely recommend that. I think Percy actually flagged a link for Magnet, which I use all the time. It's this thing that I use to kind of move my windows around. Just based on hotkeys, you can also drag things around to like the side of your window, kind of like Windows does. Although I turn that off because I don't particularly like it. So that can be nice. So you could, have like one thing over here, your code editor over here. With Zoom, it's a little bit harder because you kind of need a lot of the screen. So I'd probably, if you're able to, I'd recommend trying to see if you could get a second screen. That's probably the best thing for you as far as productivity goes, and kind of making sure you're able to jump between what you're seeing on my screen and writing your own code. That would be kind of my best option for you. So if you have a TV, then you could generally grab an HDMI cable and hook your computer up to your TV. Then you've got a second screen that way. So you could do that if you don't necessarily want to go out and buy a monitor. I have a couple students in my last cohort that they'd be sitting on their couch and be like staring up at their TV, which is great. So if you've got that, that's awesome. Or an Apple TV, even better. You can just AirPlay it up. So
That was actually my question. How do you hook up a 2019 MacBook to a TV?
yeah, so you're going to need to get like a dongle, or yeah, Sean's saying check eBay. eBay would be definitely awesome as well.
What you can do, like if you have a Fire Stick or Roku, you can download an app that
I don't.
The MacBooks normally come with an adapter, no?
I don't think
Mine
so.
do not.
I was gonna
You
say
need like a be my USB-C.
No, you have to get it yourself.
personally better investment, honestly, because it's like going to be $55 for like a one of those connectors. You might as well just buy like a Fire Stick for $30 and use the AirPlay feature.
Yeah, I mean you can get these like.
Are they actually that cheap now?
Just, yeah.
Yeah.
It's crazy, huh?
Oh wow.
Yeah, like that just has an HDMI, or these are nice. I have one right here for my MacBook. It's got like an HDMI port, a couple USB charge through it. So that's an option as well. If you have a newer MacBook, that's kind of what you'd have to do.
All right, thank you.
So yeah, I hope that helps. I definitely get working off of a MacBook screen is hard. So anything you can do to get like two screens, whether it's through an iPad or TV, that would be awesome. Yeah, it looks like James has got a dongle going on. So it's those new MacBooks, you're kind of living in the dongle life. So all right, let's get back to the code here. So let's talk about type safety. So we kind of already looked at this a little bit, but for example, if I said, I want my, let's go ahead and write this. This isn't going to work, and then we'll comment it out and we'll talk about why. Whoops, sorry. I'm gonna put price here equals, then I'm gonna say, you know, like $400 kind of as a string here. And Xcode should yell at me here. Oh, you know what? It's a constant. That's why it's yelling at me first. So sorry, let's change this to a variable, and then it's going to yell at us for a different reason. And that's kind of what I actually want to look at here. So I apologize, I did that kind of quickly. So turn that into a variable and then make this little section down here. Okay, and then it's yelling at us here. It's saying cannot assign value type string to type float. So if my Xcode will respond, oh, maybe it's just not. There we go. Yeah. So we kind of get this exclamation point in this stop sign, and that just says there is no fix for this. You need to just change the code because this is just completely invalid. So we could say, oh, right, yeah, I can't ever, you know, once this type is set, it's set. I can't ever change it. Even if it's a variable, I can't change the underlying kind of thing that it stores from being a float to a string or a double to an int or anything like that. So that's kind of the concept of type safety, like we were talking about, and this being strongly typed. So cool little hotkey. I'm super into kind of hotkeys and trying to make it so that I don't have to move around as much. If you hold the command key and then like go to the line that you're wanting to look at, whoops, sorry. Go to the line you want to comment out and then hold the command key and then type just the / key, right? Or same as the question mark. It'll comment out that line, and you can also select multiple lines and comment them all out kind of at once here. So that can be kind of a nice tool. So you don't have to run to the start of the line and then start adding your / here. So we'll leave that as an example, but it's not going to compile in our code, so I'll just kind of comment it out so it ignores it. All right, so let's get into, I think it was Ben's question about, you know, if you've got two things that you need to like do math on or something and they're not valid, they're not of the same type, how do you do that? We need to use some form of converting either one of them into the other. There's this concept of type coercion that exists in other languages that's kind of a freebie. So as an example, if I had maybe like our iPhone count, maybe we said we've got 10 iPhones here. If I wanted to say, you know, maybe I want to know like the total price if someone wanted to buy all of the iPhones that we had, we could say bar total price equals, and I could say iPhone count, or let's actually do our price first. Not that it really matters, but I'll kind of show you why I want to put this at the end here, times our iPhone count. We're going to run into an issue here. It's going to say binary operator asterisk here cannot be applied to operands of type float and int. So we've got a couple incompatible things going on here where one is a float and one is an integer, and we're like, they're both numbers, why can't you do this? And it's not able to kind of make that mental leap. And Swift as a language does not try to kind of coerce or change things under the hood for you. So it's on you to do that conversion yourself. So we're either going to need to turn price into a float or int into, or sorry, price into an int, or our iPhone count into a float, sorry. Does it matter which one we do? Does it matter which one we convert? Kind of a look at kind of here arguments for both sides.
Depends on what you want your total to be, if you want it to be an integer or not, and based on what you want your total to be, I guess you would choose if it's a float or a double. Or
yeah. What would happen if we turned it into these all into integers? What would happen?
Our total would only be whole numbers.
Would only be whole numbers, so we'd lose a little bit of that precision, and we'd maybe end up selling these for more or less than they're actually worth based on whatever the price is. So probably in this case, we'd go for having a little bit more specificity rather than kind of losing a little bit of the information from our floating points here. So let's maybe say we want to turn the iPhone count that's right now an integer into a float so we can actually do this conversion. The way that we would do that in Swift is we're just going to create a new, it's basically taking that value that is an integer and making a new float out of it. I'm going to do it here on another line to start with, and then we can kind of do it in line, but to start with, I don't want it to be confusing. So I'm going to say let float iPhone count equal. And then what I'm going to do is call float, the type float. And then I'm going to open up a parenthesis here, and it lets me actually give it the value of something else. So I'm going to put in iPhone count. So I want to make a float out of whatever my iPhone count is, regardless of if it's 10, whether it's 0, whether it's 1,000,000, doesn't really matter. I just want this to be now kind of a copy, but in the format of a float here. Does someone have a question? I just heard someone unmute themselves.
Hey, so if in this scenario is price, is that a float?
Price is a float, yes.
Okay. Okay. So down here, could you not do where you have float beside iPhone count? Could you not do float in that that operator with the operator down there?
Like by doing it right here? Or right here?
Right here, right there.
Yeah, or doing like this right here?
Yeah, doing that right there.
Good. Yeah, I'm doing this like a little bit longer of a way, and then we can look at that as well.
Okay.
Yeah,
cool.
You're totally right though. So now we could say, all right, now I've got kind of a copy here that's in the format of a float, so we could put like float iPhone count, and then that would be able to work, and we get, you know, $3,999. We could do exactly what Diego's saying, and actually, we don't even have to make a new constant for this. We could just kind of do this in line. So if we maybe pulled this back, instead of doing our float iPhone count variable, we could instead just say float iPhone count, just like we did right here. It's the same thing, just without making a constant for it. So I'm just going to get rid of this line. We don't actually need this. This is just nice for like a quick conversion. We just make a brand new instance of this number, looking at kind of that original value, but now in the format of a float. So Ben, does that kind of answer your original question?
Yes, it does. But it brings up another question. Would be doing another line of code doing this? Would that be more efficient, or any reason we would do this instead of just go back and make another variable a float?
Up here?
Yeah, where you just.
Yeah, I mean, it really depends. Like in this situation, absolutely, we could put this as a float. But sometimes you just end up getting something that you're not able to change kind of after it just comes out as like an integer, and you just have to deal with it that way. You can't feasibly, you know, say I want this as a float. Sometimes it's coming from some code that Apple wrote, and it's just always going to come back to you as an integer or some other type.
Okay, cool. I see.
So kind of knowing how to do that conversion is great, because sometimes you just don't have that control. Where here, absolutely, we could do that though.
Hey, Spencer.
Mm-hmm.
So on my in my playground, it's showing like beside the variable where you did the multiplication operator, it's telling me binary operator cannot be applied to operands of type floating integer or floating int. What am I doing wrong? Because I'm just going along with you.
Did you put the iPhone count in the float, or was the price in this kind of float parentheses here?
I did the I did where I did where you did the first time, where it's the float iPhone count equals float parentheses iPhone count.
Then that should work just fine if you have float iPhone count, as long as you've got this right here like as float parentheses iPhone count.
Okay.
Here, let me do this just so you can have it as what I've got here. I'll throw that in that notepad channel.
Okay.
Sorry about that.
That's okay. It's probably something I did. I might have typed something wrong or something.
Oh, you're good. No worries. All right, so let's move on here. Oh, sorry. Does someone have a question? You're good. You're good. You're more than welcome to ask.
Is it because where we do price times float, that's a line is lower than where the one that's giving us an error is, right? So it's not counting on the top line. It's not counting iPhone count as a float because that procedure took place underneath it. No.
Yeah, you would definitely need to use this new float iPhone count if you are using this. It's not actually changing the original iPhone count. That's still an integer here. So if you've got iPhone count here, it's still going to yell at you and say, hey, this is an integer because it's still looking up here as opposed to the new variable that we made up here.
Okay, that's actually what's wrong on mine.
Oh, gotcha. Okay.
Yeah.
Thanks for pointing that out, Ben. That's awesome. Yeah, and that's the whole thing, is that coercion never happens. If you ever want to change something, you basically just end up making a copy of it and leave the original one alone. That's a great distinction. I appreciate you kind of bringing that up here. All right, let's move on here. I want to make sure we get through everything in a reasonable amount of time. All right, so let's talk about strings. Strings are something that we end up using all the time. So I'm going to pull up the iOS simulator and I'll kind of show you what I mean here. We can talk about ways of kind of combining strings together to make something that is, you know, just something you would maybe want to show in your app. So if we look at maybe stars here. This is an app we'll make in probably a month or a month and a half from now. It looks super simple. All we're doing is we're able to add a star and the distance from the sun. I have no idea what this distance is, so if someone calls me out, I apologize. So if I say it's like 5.5 light years away, what we're doing is we're typing some text into this, what we would call a text field, and this is just a string of text. We're able to kind of ask this text field, hey, what is the text that the user put in? And it'll say Antares and 5.5. And I'm like, sweet, I want to grab those. So when I hit create, watch what happens right here. It'll add a new little cell here with those names. And we can see, for example, I just put 5.5 in here, but then now at this kind of bottom label, it says 5.5 light years away. So we're kind of adding two strings together to make it fit in one little label, one little place here. So we end up using strings a lot to, for example, just show information. So very often we end up combining strings to do that, to say we'll take a little bit of user information, we'll take a little bit of information maybe from the internet, or we just kind of hard code it to say, you know, whatever number they put in plus light years away or whatever. So we've got a couple ways of doing that. Let's look at the first one, which is called string concatenation. We can actually use the plus operator. They've kind of expanded the plus sign to not just be useful for on numbers, but you can actually use it as a way of saying, hey, let's take the string that's on the left of the plus sign, the string that's on the right, and kind of squish them together into one. So if we did something like we just say maybe label, or let's say like height label equals, we could do the height is space, well, no, let's not do a space. We could do plus 200, assuming that these strings come from two different places. I know we could just write this as one string and that would kind of call it good, but this is, again, just out of example here. So you could say like the height of something is 200. Now, if we look at this over when we run this code, we get this as the result. So it's kind of combined it into a single string. And if I option click, it just says this is one string here. although there's a little bit of an issue with this. Can anyone spot what's kind of wrong with this string here?
Left that space.
Yeah, we don't have a space here. So we've got a couple options. We could say, well, we could just add a space right here, and then that would fix it. Or the cool part about string concatenation is you can actually concatenate or combine as many strings as you want. So in theory, you could do something like this. So maybe you're pulling information from, you know, one text field and you want to pull some information from another one, and you pulling it from all these different places. You can end up combining these strings through this string concatenation and kind of putting it all together into one big kind of combined string here. What questions do you have about how this is working or anything?
I'm still a bit kind of, I guess I'm misunderstanding why putting that space is better. So my question would be, I understand that it's like about string concatenation.
Sure.
I guess my question would be, why would you not just throw that space in after the is? I mean, isn't that?
Oh, no, you totally could. I was just showing like, this is just an easy way of saying like you can concatenate multiple things, but that's totally fine as well if you wanted to do it.
I guess one reads better if it's the way that you have it with the concatenations like that. Yeah, I guess that kind of would read better if you're reading through someone's code.
It might read a little bit better. I would honestly, if I were to look at your code in like a code review, I wouldn't personally have an issue either way. I think it ends up being the same thing, unless you've got sometimes where like maybe sometimes you want a space, or then sometimes it's like you need to add like, you know, isn't or something onto that. Then it's like maybe you want this extra place to do concatenation, but that gets into kind of a little bit more specificity than we're kind of needing to worry about right now.
All right, cool. Thanks.
Yeah, no, great question. So either way is great. This is just a way of showing both of those. Other questions with string concatenation? So we do run into a limitation here where if I wanted to do like plus 200 here, we again run into our issue of having things be strongly typed. And even though you can add numbers together with the plus sign and you can add strings together with the plus sign, you can't add them kind of both together, if that makes sense. So you'd have to turn your 200 into a string, either just kind of by wrapping it around quotation marks, or the next thing that we'll look at kind of is a way of doing that conversion for you as well.
Quick question: if let's say we're string concatenating like crazy and it goes into multiple lines, is that possible?
Mm-hmm. Yeah, you should actually be able to do multiple lines here and have that not be a problem at all. Not that I would necessarily see that too often, because probably the large amount of text that you're going to have is probably in a variable somewhere. So you could do something like, I think I have like, yeah, so if I do like my name, this isn't going to make sense, but we could do like plus Spencer, or let's see, plus my name. The height is Spencer, and that's completely fine. So you would generally end up doing something like that. But yes, if it goes on to multiple lines, there's nothing wrong with that. Did that answer your question? Is that kind of what you were asking?
Yeah, no, that's perfect. Thank you.
Awesome. And that's the cool part, is if you have a variable or a constant that is of type string, you're more than welcome to concatenate that, because it knows the underlying value itself is itself a string. So that's a completely valid thing to do, and probably a little bit more realistic. All right, let's take a look at string interpolation. So this is more or less another way of doing what we just did with string concatenation, although there is a little bit extra functionality which tends to be what people tend to prefer as opposed to string concatenation. I want to preface this by saying there's like a ton of overlap where if you could do one thing with string concatenation, you can probably do it with string interpolation and vice versa. So it's sort of up to you on which one you want to choose, because there's just so much overlap there. And then we'll kind of take a look at even combining the two. So we could do something similar where maybe we have something like this. We have like a width variable that's like 100 or something. That maybe is an integer. It's not an actual string. Whereas if I tried to do that with a string concatenation, it wouldn't let me. If we actually use string interpolation, it will. And it has a little bit weird syntax. I remember when I first learned this, like my fingers felt so weird going up to like this backslash and the parentheses here. You get used to it, but it's a little bit weird at first. So what I'm going to say is maybe we say like let width label equal, and then we'll put this into quotations here. And we'll say like the width is, then I'm going to do that backslash, so it's right above your return or enter key. I'm going to open and close parentheses here to make it look like this. Oops. And then what we put inside of these parentheses is the thing that we want to interpolate or kind of put inside of this string. And like it says here, the cool part about this is they allow strings or non-strings values to be placed inside of a larger string. So that means it'll actually do some conversion for us where it doesn't convert the original width itself, but it makes a copy kind of for us like we did up here with this float iPhone count. It's just able to kind of do that whole thing for us behind the scenes. So if I say the width is interpolated width, that's a completely valid thing. And it ends up being exactly kind of what we would want it to look like. And the cool part about this, just like with a string concatenation, is you can interpolate as many things as you want. Don't do this, but just as an example, I could say my name is my name. You can interpolate as many things as you want in a single string, and it ends up being just fine. So that's pretty cool. And it tends to be a little bit easier. You don't have to convert things into a string yourself. It just ends up doing it for you. So you're welcome to pick which one you use, and oftentimes, again, like I said, there's overlap, so which one you choose generally isn't a huge issue, but you could, you know, kind of combine them together if you wanted to. And there's nothing saying that you couldn't use both of them at the same time. We could say, you know, don't do this, but again, like plus, you know, height label or something. So I'm like pulling this string into here as well. Like that's probably way more than you'll really ever do realistically, but it's possible you could do that. You get, you know, that whole thing going on there. So it can be, you know, and that's essentially how between either string concatenation or interpolation, we end up doing something like this where we probably have a variable for our amount of light years away from the sun in this string interpolation here, and then we just say, you know, space light years away, and we just write that out and kind of hard code it. Are there any questions about string interpolation here? We feeling okay so far? Okay. Are we good to move on, or do you guys need a break? Thumbs up as in you're good, or you want a break?
All good.
We're good? Okay. Let's keep going for maybe 7-8 more minutes here, and then we'll take our last break here. So let's talk about collections. So think about the situation where you go grocery shopping. Maybe, sorry, I don't know why. You'll notice that I tend to go over like an example of grocery shopping for whatever reason over and over again. Let's say you go grocery shopping, and as you are grocery shopping, you're like, oh, I want some cereal, I want some hot dogs or whatever, and you start to grab things. And instead of you having a shopping cart to put them in, you have to just kind of hold them, and you're just trying to like manage all of these different objects, these different food items yourself. That would be a lot of work, and that's kind of what an array does. Is it takes away that that work of saying, maybe I have 100 things I need to keep track of, like 100 student test scores or something. What we could do is we can make a collection, and if the first one is an array, and that's sort of like your shopping cart, where you can say, let's just throw everything inside of this, and the shopping cart can manage holding all of those, and really all I have to manage is pushing the shopping cart itself and just kind of manage one thing, and it itself manages everything inside of it. That's kind of the whole point of arrays, or really collection types in general, to say we can store like things together, not have to manage a variable for each one. Moving all of those around in an app would be a pain, whereas now I can just move one thing, that is the single array. It makes it a lot easier. So let's make a bunch of, we'll say we want to make an array of, we're going to call it shift captains. The syntax here is the square brackets, so it's a little bit above and probably to the left of your enter key. And anything you put inside of these square brackets are the, what you would call the elements inside of the array. So sort of like the individual food items in your shopping cart. So we'll maybe start with Malcolm Reynolds. And this is going to be specifically an array of strings. So just like we explicitly set the type of a constant up here, like our width label or our width, to an int or a string, an array can only hold a type, a set of one type of things. There's kind of ways of getting around that, but we'll talk about that later when we get into protocols. For now, just kind of assume once you've got like a string in here, all you can put in this array now are strings. Like I couldn't put 100 in here, it would start yelling at me. So that would be like I have one item in my shopping cart, which is possible. Maybe you even start your shopping cart out as not having anything in it. But as we start to go grocery shopping, we add more and more items on. What we do to add another item to this array is we're going to put a comma here. Then I'm going to put, like, we could do John Luke Picard. We'll do James T. Kirk. And we'll do Han Solo. Putting commas in between each of those, and you'll get used to that syntax. It's kind of weird going from quotation marks to commas, but it's easier. You're welcome to just keep writing that. I'm just going to option click here. I'm not going to write anything. And it just says the ship captains is of type bracket string. So it says this is an array of strings, or essentially just a group of different strings that we are holding in a single constant called ship captains here. So as an example, maybe I then am, pulling everything out of my shopping cart to put into my car, and I'm like, oh, I want to make sure that I don't know, put the milk in first so it doesn't like squish the bread or something. I don't know. There are many ways that you can use arrays, but if we're like, I'm looking for the milk specifically, and maybe like James T. Kirk is what I'm looking for in this array. Arrays they use what are called indexes. So it says accessing a particular element is done by using its index value. So this is a little bit weird if you're not used to this. The indexes start at 0, which means the first item in the array isn't actually sort of at position 1, but it's actually more at position 0, which takes a little bit getting used to. So if I said, what is the index of the third item in the array? What would you say? This one.
Han Solo?
Oh, Han Solo.
Well, yeah, sorry.
Space number 2.
Yeah, so yes, sorry, I need to be more specific here. If I said, what is the index of James T. Kirk, what would you say?
2.
2, right? It's the third thing, but it's the second index, which is weird to get used to. So let's do that. The way that we access these elements here is by using what's called subscript. So I'm going to type ship captains, the name of my constant here. And then I'm going to do open and close these brackets right after with no space in between here. And then I'm going to put the number 2. And we'll get back James T. Kirk. So just for example, if I do 0, it'll pull out Malcolm Reynolds, right? And that's why it says it starts at 0. The first thing in the array is really the 0th index. So what do you think happens if I do something at like, maybe I forget that and I say, well, I want to access the 4th thing, so I'm going to put a 4 here. What do you think happens? You could try it.
It's going to put an error and it's out of bounds, basically, or out, whatever.
Yeah, I like Craig's. It's going to explode, right? Yeah, you're going to get an out of bounds, or in this case, it's going to say index out of range, and this is actually like a crash. If you were to do this in a real iOS app, that would be like the app just goes straight to the home screen and you have unhappy users because the app is crashing. So we need to be a little bit careful about how we use our indexes, and we'll get into that when we actually start building full iOS apps, how to kind of use these indexes safely. But definitely be aware of, if you try to access something that doesn't exist in the array, it's going to crash. Or rather, access the index, use an index that doesn't exist in the array. Questions on our array here? Okay. Let's stew on that for a couple minutes and take our second break. And then when we come back, we'll use these arrays a little bit more, dive into dictionaries, and then talk about our last couple topics here. So I'll see you all in 5 more minutes. All right, welcome back, guys. Okay, let's dive back in here. We've got a fair amount to cover, so I'm going to kind of go at a slightly faster pace here. If I'm going too fast, let me know, because if you think it's too fast, probably someone else does too. I try not to go over time on my lessons. I really try to kind of have us all get out when kind of we're trying to. So bear with me here. If I'm going too fast, let me know though. So as far as these ship captains go, we can check for equality on these ships, or sorry, these ship captains here, by doing a little bit of conditional logic here. And you're able to compare strings, numbers, but also entire arrays themselves. So what I'm going to do here is, let me just give you a small snippet of code that is just a different array, so we don't have to write them out. It's in that notepad channel, and it's just this different captains here. So really, it's essentially the same thing. We just have different captains in here, but it's just another array of strings here. So we can actually just say, hey, I want to check and see, are these captains the same as the other captains or not? So we could use an if statement, and this is just like, if you remember from like your English class, it's like an if-then statement. It's essentially that kind of same thing. We just say, if some condition is either true or false, then we'll do something. And optionally, we can say, otherwise, we want to do something else. So I'm going to say, if ship captains equals equals, so two equal signs right next to each other, this is essentially saying is equal to our different captains. And I'm going to open and close these curly braces here. So as you open up this first curly brace that's right above your enter key and to the left a little bit, same as the same key, just by holding shift as the square brackets. Once you hit enter here, it should automatically throw in an ending curly brace for you, kind of auto-complete that out for you. So the whole thing here with these are, any code that you put inside of here will only run if this conditional statement is true, meaning that both of these captains on the left and the right are the same. And if they're not, then nothing will happen. In this case, we know nothing's going to happen, but let's go ahead and write this anyway. So I'm going to say print, and then I'll just print out a string here to kind of go in our console down here. We'll say the arrays are equal. And if I run this, we see nothing, or at least that doesn't get printed down in our console here. So sometimes you just have an if statement. You just want to check kind of one condition here, but sometimes you're like, well, I want to also check if it isn't the same as the other array. So we could say else, we want to print the arrays are not equal. And I shouldn't have anything wrong with that. There we go, that was weird. So we've got two print statements here, but only one is running because we're kind of now branching out our paths, the directions that the code could run, and say, based on this condition, you could go over here, you could also go over here. And that's really kind of the basis for everything that ends up happening, is just kind of having these branching paths based on whatever conditions we need to have met in our apps. Are there any questions about how this ends up working here? On top of this, there's also don't do this, but just kind of as a reference here, you can do not equals, and that is going to say, if they're not the same, then it's not going to make sense. It's going to print that they're equal here when we know they're not. But it kind of flips that logic to say, I want to know when they're not equal and handle that kind of first. Otherwise, we want to do something else last. So that's also kind of a nice tool here. So let's talk about actually adding things to our array. So maybe we just have our array of captains here, but we say, well, I want to add some more later on here, like Poe Dameron and Catherine Janeway. So let's go down to this little section here that says, since ship captains were declared as a constant, and I'm just going to say var new, or we'll call it more captains equals, and then I'm just going to kind of make a copy of my ship captains and say, making a new variable called more captains, and I'm going to set its value equal to whatever ship captains currently has, which in this case is going to be our 4 captains up here. As far as adding things to the array goes, we have a couple options here. The first one, and probably the one that you'll end up using the most, is what's called appending an element to the array. So if we just say more captains, whoops, we'll explore this syntax as we continue on. It's sort of something that just we end up using all the time, although it looks a little bit weird at first, is I'm going to say dot, and then it's going to pull up the autocomplete here after a second and kind of give me a bunch of options as far as what properties and functions exist on this array. And one of them is this append here. And you can just kind of select which one you want and then hit enter, and it will kind of autocomplete out the rest of this so you don't have to write it yourself. We've got 2 options here. We have this new element, which is ultimately what we're going to want. This append contents of is like if you want to give it the contents of basically like another array, you could just say kind of mash these 2 arrays together into one. But we're going to say we just want to add 1 string at a time here, which is what you end up using this dot. Or this is how you end up using or adding things to the array. So we could say, maybe we want to put in, we'll do our, well, let's start out simple. We'll just do like Poe Dameron here as just a straight string here. And if I were to print out my my more captains rather, not the ship captains, then I'd have the 4 that came with it, but then Poe Dameron here would be at the end. So the thing with append is it's always going to put it at the end of the array, always, always, which it generally is completely fine. If you want a little bit more control, then all we really have to say is, well, I want to put it at a specific place at a specific index. So we could do something like, if I said more captains dot, instead of append, we're going to do insert new element at an index. So like it says in our little description here, inserts a new element at the specified position. So I could say maybe I want to put Catherine Janeway at index 3 or something. Then I'm just going to hold my print statement down here so we can actually see what happened. So then we've got 0 for Malcolm Reynolds, 1, 2, and 3, we have Catherine Janeway. So we've kind of, put it somewhere that isn't just necessarily at the end, although I tend to use this fairly rarely myself. Doesn't mean you'll never use it though. All right, what questions do you have about arrays here? Just because I said I'm going fast doesn't mean you can't ask questions. Okay. As far as removing things from the array goes, it's a matter of figuring out where it exists, which index it exists at. So I could say like more captains dot, and then there was this remove at index. So I could say remove at position 0. I want to get rid of Malcolm Reynolds. Then I could print that again, kind of down here. And then now Malcolm Reynolds is gone from the 0th position. It's just completely gone here. So that's how you would kind of pull things out of an array to say, I don't care for this anymore. At least that's kind of the most common way. There's also like remove first, remove last, depending on kind of what you're trying to do. That could also be an option as well. All right, let's take a look at dictionaries now. Dictionaries are basically what they sound like. So if I asked you, hey, will you go look up the dictionary definition for X word, then you would pull out your dictionary, flip to that page, and tell me what the definition is. That's really all a dictionary is here. We have the key, which would be maybe the word, and then the value, which would be the definition. So let's go ahead and make a dictionary here. So let's say var occupations. And they start out the same way. I'm going to open and close parentheses here. But then we have kind of two things for each element of our dictionary. It's called a key value pair. So we need to specify the key and then kind of the corresponding definition or value for that key or kind of word in kind of like an English dictionary. So I'm going to say Malcolm is the key. And then I'm going to put a colon here. And then I'm going to say the definition is, I'm going to do captain. And what this lets me do is maybe if I, somewhere in the app, I'm able to say like, hey, I know the name of the person I'm trying to look up their occupation for, but I don't know what that occupation is. You can ask the dictionary, hey, can you give me the occupation for Malcolm as the key? And they will return you the corresponding value that goes along with that. So let's add one more and then we can try this out here. So we could say Kaylee. So I'm gonna, between these key value pairs, I'm gonna put a comma to separate those. So between the key and the value itself, there's a colon for that pair of the key and the value. Then between each key value pair, we have a comma here. So then I'll put like mechanic. And you could keep going for as long as you wanted to. We'll kind of stop it there. But then what that lets me do, like I said, is I can at any time ask my occupations dictionary. And we end up using that subscript looking syntax here with these two square brackets here. And I'll pass in the key. So I'll put in Kaylee. And it's going to return me mechanic. This may not seem necessarily super useful right now, but when you're dealing with maybe a large amount of information or you're just trying to kind of match one thing to another, these dictionaries can be fantastic. Or you could maybe make like a, just kind of watch me here. I just want to point one thing out. You could say like var ages, and maybe Malcolm's age is like 40 and Kaylee's age is, I don't know, like 32 or something. That's completely valid too. The keys and the values don't have to be the same type. So the keys could be strings, which generally the keys tend to be either strings or integers. And then the values could be essentially anything. There's a little bit of a limitation, but we can talk about that when we get into protocols here. But then I could say, hey, I don't remember what Kaylee's age is. We could ask the dictionary and it would give us back 32. What questions do you have about dictionaries so far? Okay. So let's talk about adding something to our dictionary kind of after the fact. Maybe we don't have access to the kind of original definition of this, but we say, hey, I've got like a new person whose occupation I want to add here. So we could say occupations, I'm going to say add the key Jane equals, and then we're going to say public relations. So I think this is kind of a weird looking syntax. This one, for whatever reason, always kind of tripped me up. But we say the occupation for the key in the dictionary, Jane, equals some value. And it's sort of like us going to a blank page in the dictionary and writing Jane, and then under it is like the actual definition there. Just us kind of adding on to our own kind of custom dictionary here.
I have a question actually.
Yeah, go for it.
So with these, when I call, like say for instance, Malcolm is the manager, can I do occupations manager and then that would tie back to Malcolm, or do I have to do the dictionary every single time?
Yeah, so it only goes one way. You're only able to use the keys to get the values, but not the other way around.
Okay, that makes sense.
So generally, it's a matter of trying to figure out which thing you'll have access to and which thing you won't, and then kind of figuring out the thing I'll have access to, I'll probably use as the keys, and the thing I'll want to get later ends up being that value. And it turns out that, you know, not every time dictionaries are the solution. Sometimes there could be some other way of getting those values if you needed to. Does that kind of make sense?
Yeah, definitely. Thank you.
Okay, awesome. Removing things from the dictionary, you can do it a couple ways. You could just say, like, occupations at key Malcolm equals nil, or essentially nothing. That would work great. There's also, I believe, remove at, or remove value for key. That's probably a little bit nicer way of at least I would maybe prefer that. But so let's talk about, we already said, you know, if you try to access something in an array that doesn't exist, what happens? Maybe I misspell Malcolm and I try to get the occupation. What do you think happens here? It actually doesn't crash. Dictionaries are a little bit smarter than arrays. And it really just comes back and gives us nil. Again, that kind of just stands for nothing. Think about it this way. If I ask you to look up the dictionary definition for a word that doesn't exist, you'll kind of come back to me and say, sorry, I couldn't really give you a definition because the word doesn't exist in the dictionary. So I can't give you anything. I just give you nothing back, no definition. It's kind of what happens for the dictionary. So it's a little bit safer in that way, where you can kind of ask the dictionary for a definition kind of as much as you want, and you're sure it's not going to crash, which is kind of a nice feature. All right, let's talk about looping here, and then we're kind of starting to wind down in the things that we need to talk about. So let's say I have again, I'm gonna maybe just slack this little snippet to you so we don't have to write it out. It's just a small little array here of scores. And if you want to put extra numbers in there, less numbers, that's cool. What I'm gonna do is we are going to write an if statement that checks if the scores are, or I'm going to say if a score is above 70, and if it is, we will increase the count of passing students. We're going to have a variable called passing students here. So if we say we have this variable called passing students, and I'm just going to set it to 0 by default. We're going to say no one's passing until we actually run through these scores and kind of run that check. Let's start out like this. We'll kind of write it without the for loop, and then we'll add the for loop in, and you'll see there's like not really much work that you have to do. So let's make a quick temporary variable just called like a score, and we'll say it equals 88 or something. It doesn't matter. really all we have to do is write a little bit of logic to say, all right, is this greater than 70 or is it not? And then if it is, we'll just say we want to increase that count of passing students by 1. Does anyone have an idea on how we could do this if statement here?
By using an if statement?
Yes. So if, what would we write here?
Oh, what was the question?
So I want to write an if statement that says if our A score here is greater than 70, then we'll do something, but we'll just start with that part
If scores greater than and equal to 70.
It's exactly like that. If score greater than 70, open brackets, print whatever it is that we're gonna print that, yeah, it's accurate, and then we can just keep doing else if we want all the way to like 20 of them.
Exactly. Perfect. Yeah. Thank you. So in this case, we'll just increase that count of passing students by 1. So we'll say passing students plus equals 1. So what I've done here, and now we see that the passing students becomes 1 right here. So what we've done is we've written this logic, but then if I say, well, I now want to apply this same check to all 6 of these scores, or what if I have 1,000 students? Then it's like, I definitely don't want to do that myself. So what we could do is we could say, hey, can I just apply the same logic to every single element in this array to have it do it for me? The answer is yes, I can. So all we would do is we're going to say, sorry, let me get rid of that line there. There we go. So I'm going to just write this below here, and then we'll kind of paste in this code. So I'm going to say for score in scores. So scores here is coming from this let scores above. Kind of a really cool trick of Xcode. If you're ever unsure where something is coming from, like if this is something you're just now naming, or if it's from a variable that you made before, if you just click on it and kind of sit there for a second, it will highlight this, and it will also highlight where it's coming from as well, and any other times that it's being used. So you can know this is the same thing. It's referring to the same array in this case. So what happens here is anything I put inside of these curly braces is going to get applied to every single score here. So let's just essentially do the same logic here, except now my variable is called score instead of a score. So we could just maybe pull this out. I could select the text and do Command X here and paste that in. And then all I need to do is make sure that I change this from if a score is greater than 70 to just if score. So again, we're using this one, and I'll kind of talk about how this is working here. So we would call each time this loop runs an iteration of the loop. So the first time our loop starts, it's going to say, I'm going to make a constant called score here. And what that's going to do is look inside of our array that we put to the right of this in, and it's going to say, all right, score for now is sort of a placeholder name for our number 30, our value 30. And then it's going to go through and it's going to say if score or 30 is greater than 70, add that, and it's not. So it'd say, all right, I've reached the end of this loop. I kind of get to this point. And then what it says is it's going to check, do I still have more scores to look through in the array? And it's going to say, oh, I do. Okay, let me grab the next thing, and that will become score. And so score just becomes this variable that gets reused over and over again until it goes through each and every one of these numbers here. So then if I were to run this now, we'd see over here, this ran 4 times. So it looks like I had 4 passing students, and we could actually, under our for loop, print out the passing students so we'd actually know how many there are, and we should get 4 in this case. But again, here's the cool part, and you can just watch me here. If I have a bunch of scores here, the loop doesn't care. It's like, oh, okay, cool, I'll just do this more times, and it says yeah, out of all of these scores, you've got like 64. And that's the kind of nice part about this is you just tell the computer how to do it once and say, apply the same logic to all of these things. And it's like, cool, I'll go ahead and do that for you. Any questions on these loops? Do we feel okay with how this, well, here, I want to say one thing real quick. You can name this for something in whatever you want. So the keyword for and in needs to be there, but whatever you call the thing in between the for and in is free game. You just call it something that makes sense to you, but it doesn't matter. So I could call this for foo for all I care. And I could say if foo is greater than 70, and the logic would still work the same. Again, it's just kind of a placeholder proxy name that all of these values kind of get thrown into when it's their turn to go through the loop.
So after you do 4, it just kind of automatically goes to that array of scores.
Yeah, and we specify what array we want to go through by putting it.
So after 4, you're just essentially naming the loop.
Yep, exactly.
Okay. Okay.
So if we wanted to go through a different array, we just have to pass in that array here instead, and then it would go through that one. Does that make sense?
Yes.
How do we feel about this? I think loops are maybe one of the harder things to kind of understand here.
So if scores was a variable, so if you said like if score is greater than 70, and then you wanted to round up some of those numbers for the passing students, to say hypothetically, then you'd be able to change the score, right? But in this instance, score's a constant, so you couldn't really do the roundup thing. Is that correct? Am I thinking that right?
Yeah, you probably wouldn't even be able to do it then. You could definitely get around it, although I think it's probably a little bit more work than I'd kind of be comfortable with. Let me just try it right now.
Like if you're a teacher, like people have 69%, right? You want to round up to 70.
So it's not going to let me do that. We kind of run into some issues with the way that these variables are. Yeah, we haven't even talked about structs or classes or anything. It happens to be an issue with the way that these are kind of created behind the scenes, and they're making copies of these. It's not actually kind of referencing the original version. It just says, let me make a new integer called of the value of 30. So it's a little bit more complex. In a couple weeks, we could definitely talk about that and talk about how to get around it. But it isn't quite as simple of a problem as it kind of looks on face value.
Yeah, gotcha.
Does that make sense?
Yeah, that makes sense.
Okay, sorry. I feel bad kind of leaving you there hanging, but if you want, like, we can revisit it in a few weeks.
Or I could just Google it.
Yeah, that's true. All right. Any other questions about loops here before we move on? Okay, cool. So let's go over to switch statements. These are awesome. I love them because in most languages you have if statements, but not every language has a switch statement. This is another way of evaluating some conditional logic, just like we kind of did here with our like if score is greater than 70. But switch statements tend to be a little bit less verbose and kind of a little bit less code that you have to write. So let's say we have a constant called dice roll here, and it equals like 6 or something. And maybe I needed to handle all 6 of the possible values that I could have 1 through 6, if this is just like a 6-sided die. I'm going to copy a kind of example of this, how it would look more or less in a if statement, and then we're going to write it out the same logic and kind of actually go further with a switch statement, and we'll be able to kind of compare and contrast here. I didn't actually end up doing all 6 paths because that would be a lot. But what we can do is we can actually use if statements, not just to say if this thing, else this thing, but you can also say if this thing is 1, do something, else if it's 2, do something else. And you can, in theory, go as long as you want doing that. It just ends up being a little bit long to write out. So switch statements are kind of a way of saying, if you start to do this else statements and you start to say if, else if, else if, else if, a switch statement may be a little bit better choice just because it's less work for you and it's also a little bit more readable. So this is another one of those like Venn diagram, like you kind of have options, you would make your code work either way. So if we wanted to do more or less the same logic with a switch statement, we would start by saying switch, and then on the dice roll, and then I'm going to open and close curly braces here. Yes, I believe they are the same in Java, although my Java experience is very limited, so I could be wrong about that. But yes, I'm fairly sure they are. So what we do then is we make these things called cases. So instead of saying if dice roll equals 1, else if dice roll equals 2, and kind of doing this over and over, all we have to say is in the case that the value is 1, we'll put a colon here, and then we can evaluate that. Then we could say in the case that, whoops, in the case that it's 2, we evaluate something else, and you can keep going. And it's a lot easier to write something like this than it is to write this whole kind of long else if statement here. So again, these are just options. So in the cases, it's going to yell at us for a couple things, and that's okay. As far as these cases here go, it says these cases need to have at least one executable statement. So you can't leave them blank, is what it's saying. So let's just do something really simple here, and we'll just say print rolled a 1. And then in case 2, we could say rolled a 2. Not necessarily the most exciting code that we've ever wrote, but it starts to kind of illustrate the point here. The cool part about these cases, just like you could do with an if-else statement, you can have as much code in these statements as you want. So if you wanted to run an entire function to go do something on a server somewhere because they rolled a 1, you could do that. The amount of code you write here isn't limited in any way. And then it gives us this other error that says the switch must be exhaustive. What that means is you have to, in a switch statement, it's like you almost have to finish with an else statement where you don't necessarily need an else statement with an if. That essentially means you need to handle essentially every path that you could go down, but in the case of a number, that would mean you'd be handling millions and millions and millions of numbers where that's not really feasible. So as kind of a catch-all, we could say, well, in the case that it's not either 1 or 2, or any other case that we've made, we'll make a default here. And then that can be our place that we say, if it's not any of these things, we're going to do something else. And again, we need to have something run here. So we could either just print something, which would be fine. If you're ever just like, well, I don't want to do anything if it's some other case, then you could add what's called a break statement. And what that says is, I'm done with this switch. I don't need to run anything, but that itself is one of those executable statements. So it stops yelling at us here. To be more in line with what we have here, we could also just do, print rolled some other number. And so now these look almost the same. I think I've got like an extra exclamation point here. But looking at this, to me, at least, this switch statement looks a little bit more readable and just easier to kind of digest here than this else if statement here over and over again. Especially if you start getting into multiple paths where you start doing like else if, else if, else if, else if. It's just a lot for you to look at. It's just this big dense chunk of code where it could maybe be cleaned up a little bit by using these switch statements. So again, there's a lot of overlap. Could you do it with an if else if statement? Yes. Could you do it with a switch statement? Yes, probably. There's a bunch of overlaps. When we start talking about enums and some more complicated data types next week, we'll revisit switch statements and kind of talk about some other benefits they have. But to start with, this is kind of great. So, okay, I realize it's 8:30. So if you have like a hard stop and you need to go, that's totally cool. We're going to record this, so I just recommend checking out the recording of this video. I apologize for not getting done in time. We have 2 more things that we need to talk about. So it shouldn't be longer than about 20 minutes here. If you're willing to stay, that would be awesome. But if you need to leave, then you're not going to hurt my feelings, and you can just watch the video later. So I'll try not to do this, but there's kind of a lot of content here in this first day. Okay, are there any questions about switch statements as opposed to if-else statements, or really anything in general here? We feeling okay? Am I going at an okay pace? Do you need me to slow down?
No, I think you're good.
Okay. All right, cool. Let me know. You're not going to hurt my feelings if you tell me to slow down or go faster or something. All right, let's go over functions. Functions are so cool. Between this kind of thing that we're going to talk about here, functions, and what we'll be talking about next, probably Monday, I would believe, the third module in here. These end up being the building blocks of any app. So you'll see when we start getting into actually building iOS apps, basically any code you write is going to either be in a function or in something that we talk about next week. So functions are, just like it says here, nothing more than a collection of instructions that accomplish some task. So as an example, what we did here to check the passing students, this is a collection of instructions. So what we could do is put that into a function, and we get a cool added benefit here. It says the advantage is that the function can be called whenever the task should be performed, rather than having to list those instructions out a second, third, or nth time. So it's sort of like once you write a function, you teach the computer, or in our case, the iPhone, how to do that thing, and then you can just say, hey, remember that thing I taught you? Go ahead and run that again, and you could give it some information to say, hey, I already taught you how to check the scores here if it's above 70, so maybe I'll give you a new array of scores, and you can go ahead and tell me how many are passing or not. So any code you write could be put into a function to make it sort of more reusable, so you don't have to keep writing this over and over again in multiple places. It's just kind of like the phone learns it once, you can call that code as many times as you want. So let's do something here to say, maybe we want to average a bunch of scores that the student has, or the students have in a class, and kind of know what the class average is here. So we're gonna, well, actually, you know what, before we do that, let's make a simple function that's super basic, and we'll kind of go on and make this a little bit more complex. So let's start with, we're gonna add this keyword func to specify this is a function. I'm gonna put just print my name. This is gonna be like the most lame function you'll ever write, but it's good to kind of start with because it's easy. And then I'm gonna open and close parentheses here, and then open and close curly braces after that. So we add the keyword func to specify it's a function, and then we give this function a name so that when I want to say, hey iPhone, remember that thing I taught you? Go run this code, we refer to it as print my name. And all this is going to do is literally just call print, and I'm going to put Spencer in here, so it's not a very exciting function per se. But what that lets us do is at any time I could tell, in this case, the playground to print my name by just calling print my name and just accessing that function name. We'll talk about these parentheses in just a sec, so just bear with me here. So I could call this 3 times, and it would print my name 3 times. Again, not terribly exciting, but it illustrates I only wrote this code once, and all I had to do was say print my name. I'm like, I want to print my name again, and I want to print my name again, and it's able to do that as many times as I want. So just by grouping that code in there, we allow it to be a little bit more reusable. So again, that's not maybe the most exciting function. So let's maybe move on to having it be a little bit more exciting here. So let's do that averaging of scores, and we'll talk about these parentheses here because I kind of glossed over that. So we'll say func average scores. Then I'm going to open up a parenthesis here, and I'm going to put maybe scores in here as an array of integers. So this is probably going to look a little bit foreign to you. That's okay. What we have here, this is called an argument, or sometimes they'll be called parameters to a function. What this says is when I want to tell my phone, or in this case the playground, to run some code, what it's going to ask for is what scores do I want to average? And it says the scores need to be in the format of an array of integers. I say, oh yeah, these are the scores I want, or I could give it some other array, and it's kind of up to us. And in that way, again, this is reusable code, but I can also give it some external information based on, maybe I have some scores for today. I let it run through those and average those out. And then tomorrow I could say, hey, I've got a brand new array of scores for you. Let's go ahead and run those and see what that averages. And the computer's like, sweet, I already know how to do that. We'll go ahead and just do the same chunk of code here. So as an example, let's just call this so we can kind of see how this ends up working, and then we'll actually write some code inside of it. So when I call average scores here, again, it's going to kind of have this little autocomplete bubble here for me, and it says, what scores do you want me to average? We already have a variable called scores that we could use, or we could just pass in a brand new array here. It doesn't really matter. So let's maybe just kind of, well, yeah, let's do that. Let's just do scores here. Ooh, never mind. That's going to be maybe a little bit confusing. Let's do this. Let's just make an array here with maybe some random numbers here and just have those be averaged. Just kind of a brand new array. And then we'll talk about using the variable. So then what happens is this array of scores here is this array right here, and that's how we'll refer to this array, whatever we pass into the function, as it's just now a variable called scores here, and we can use that inside of this function. So it gets what we would call passed into the function. Oops, there we go, right here. So how do you average a bunch of numbers together? Does anyone know?
You add them up and divide them by the total number of numbers.
Yeah, perfect. So add them all together and then divide them by as many numbers as we have. So let's maybe do this. Let's have that total, we'll say like total score. We'll set it to 0 by default. And then as we add these scores together, we can add them to this total score. So how can we go through all of our scores here and add them to this total score? Something we've done earlier. I have a bunch of numbers that I want to go through in an array.
Switch statement?
What's that?
Statement?
Sorry, I can't hear you very well. You're a little kind of muffled.
Switch statement?
Not quite.
What was the question?
So if I wanted to like do something to all of these numbers, like add them all to my total score individually, go through each of these.
You can do you can
Scores plus scores.
You can do the what is it, the catenation when you add them all together?
Not quite.
No, just go out scores plus scores.
Right. So let's maybe do a for loop to say, let's go through and add 1 to the total score, then we'll add 20 and kind of go individually and add them all together. There are a bunch of ways we could do this, but that's kind of the easiest way at this point. So we could say for score in scores. Again, if we click on this, we'll notice that this highlights up to our scores array, which ends up being really this one that we kind of passed in here. And then score is just a name placeholder that we give each element in this array as we kind of go through. So we could just say total score plus equals whatever score, score that we're trying to loop through at this point. So the first time this loop runs, it's going to be 1. The next time it runs, it'll be 20. And it'll just be continually adding on to our total score here over and over again until we get to the end of the array, and then the loop stops and it'll continue running code below it. So then we could say, let the average equal, we could say our total score divided by with the /. And then there's actually, the array is smart enough to know how many things are inside of it. So it's like a super smart shopping cart that says you have 25 things in your cart, which would be super cool. You could say scores dot count, and it will tell you how many items it has in that array. And then for now, let's just print out the average. Whoops. So we'll call print the average. So if we run this, I get 52 for my array that I've passed in here. If you get a different number, then it's probably just because your numbers are different down here. But that should work for any amount of numbers that we have. So here's the thing. Now that I made this into a function, I could use my array of scores that we have from above and see what the average for those are. So I could then call average scores and pass in my scores variable that we made before. And it will say, oh yeah, well, I've got 52 for your first array, and then in this case, 74 for the second array of scores from above. And again, we just taught the computer how to do one thing over, and I can tell it to do it as many times as I want with any array of integers that I choose.
Hey, could you? Oh, there. Never mind. You got it.
Oh, just scroll up a little bit. Sorry. The thing with functions is you can make a function do anything. So there's no time to say like, what functions should I make, or when should I make a function? It's just like almost everything, right, will almost always be in a function, or in something that we'll talk about next week. So, and that's the name of the game, is writing code that doesn't repeat itself. There's this acronym called DRY that's called do not repeat yourself. So if you do something more than one time, you should probably pull it out into a function so you can just tell the computer to run that twice or as many times as you need, as opposed to writing, this whole averaging code out twice. It's just easier to write it in a function and call the function as many times as you need. You save yourself mental, work of doing it and writing it out. It also just ends up being cleaner code in general. So sometimes we want a function to just give us back a result. So in this case, it's sort of like if the teacher is averaging the scores and then they just kind of shout out like 74 as the average, and that's not necessarily useful, but maybe they need to get that number out and maybe like put it into the computer so they can know what the average is to kind of save that. What we could do is in our function here, after this parenthesis, but before the curly brace, we're going to add a little arrow here, which is made by doing the minus symbol or the dash and doing the greater than symbol. So it looks like a little arrow here between these two characters. And say that our function is going to return or give us back an object, something. In this case, we're going to say it's going to give us back an integer that represents that averaged score. And then it's going to start yelling at us, and it's going to say missing return in a function expected to return an integer. So it's saying in putting this arrow here, you're essentially making a promise that says at the end of this function or sometime within this function, I will give back an integer, but I'm not anymore, or I'm not at this point. We have the integer, so all we need to do is return it, and it's just using that return keyword. So maybe instead of printing the average here, that's maybe a little bit not terribly useful here. Instead, we could say return average. And what that says is give back this average number to whoever is calling this function. So in our case, it's just going to get returned right to these lines here. But it itself is kind of getting pulled out of this entire function and given back to whoever ends up using this function. So you'll see on the right here, now we get 52 and 74. And so what we could say is maybe like the first average scores here are like today's average. So I could even make a constant that says like let today's average equal, and then you can actually call an entire function to give a constant a value. That's completely fine. If it returns an integer, that's what you're looking for, then you can call that entire function and it'll run that code and give that value to our constant for today's average. You don't always have to have returns. Sometimes you have functions like the print my name that just doesn't take any arguments in and it doesn't return anything. Sometimes you have functions that don't take any arguments and they do return something, or they have arguments and they return something, or they just have arguments. It's kind of all over the place as far as what you want to do. More than I just kind of want to show you the options that you have here.
Hey, Spencer.
Yeah.
Just so I'm not confused. What do you mean? What are you meaning by like return? Like give back? Return to what? Exactly.
Return to whoever is calling this function. So in the case of what we had before where I was just printing, it was just kind of showing it down here, but it wasn't really doing anything with that number. Whereas now, if I have this constant for today's average, I could then take that and say, well, now I want to like save that up to you know, the teaching database or whatever. You could put it into a label so it's actually showing that number on the screen to the user or something. It's actually kind of, you're just going to take this return value and use it somewhere else in the event, if that makes sense.
Okay, I got you.
Thanks for that clarification. I appreciate that.
Oh, and also, there was something that I had a question about. I don't know if she finished talking. I forgot what it was though. It's all right. So you know how you did you declared like a constant inside the function. Are you able to recall that function later outside of? Are you able to recall that constant later outside the function?
No, so this only exists within what's called the scope of this function. So it's sort of local to just the function. If I try to call like average here, it doesn't know about that constant.
Okay, I got you.
Yeah, great question. Any other questions or comments on functions here? If we're not feeling 100% with them, that's okay. Again, like I said, you'll be using them all over the place here in the next little bit and kind of really throughout all of your iOS development career. So it'll definitely come with time. But there's kind of, again, two main parts. There is the declaration of the function where you declare what you want the thing to do. And this is like you teaching the phone or the computer what to do. And it kind of just sits there and it doesn't actually run any code until you actually tell it to run the function. You say, hey, I've got some scores for you. Go ahead and actually, you know, run that average stuff that I taught you to do. Otherwise, it'll just sit there until it's called upon by actually accessing that name of the function. All right, let's move on to our last thing and then I'll let you guys go. I apologize for going over time here. Thanks for sticking with me. All right, we have a thing called tuples. Tuples, like it says here, they're a lightweight way of grouping related values together into a single sort of compound value. For various reasons, these are going to be useful. You won't see them terribly often in sort of more advanced code. We tend to have something else that kind of takes their place, which is the thing we'll talk about on Monday. But for now, they're very useful and you'll use them in your module project. So let's say, again, we're grocery shopping and I'm in charge of like taking inventory for the grocery store. Maybe I work there. And so I say something like, let's do let carrots equal. And then maybe I need to know the name of the item and like what aisle it's on to begin with. Well, to start out with, you could do like let caret name equal carets, then you could do let caret isle equal 4 or something. But then they're in two separate constants, and you then again start to have to manage multiple things. And if you have, a ton of different items you're managing, that's just double the work for you. And then what if I say we also need to manage the quantity that we have, and then that's tripling the amount of work you have to do, or the amount of constants you have. So a tuple is going to let us kind of group those together. So we start them out by putting parentheses in here, and then I can say like carets. And then I can say comma, and maybe it's on aisle 4 or something. And what that does is I'm now able to put multiple values, 1 and 2, into my single constant here called carets. Oops. So these are a little bit weird to start out with, so I'll show you an easier way of doing it, but I want to show you why they kind of end up being weird. If I'm ever like, well, I need to print out what the aisle, or we'll do like the name of our carets are here. If I go to print my carets, we access these individual values within our tuple by using that dot syntax, but the ways that it gives us access to them by default isn't very user-friendly. So if I say carets dot, it gives me a 0 and a 1. So these essentially have their own indexes here. So the 0 thing it looks like a string here, so that would be carets, and 1 would be our number 4. So if I say carets.0, then it will print out carets, which is a little bit weird. It doesn't feel very natural. I don't necessarily like knowing, or having to remember, what does this number mean? So what we could do is add a label onto this, and we could say, well, that's a little bit hard to work with. Let's instead just manually give a name for each of these properties within our tuple. So I could say name carets, then I could maybe say like aisle : 4. And then that way we don't have to deal with this weird 0 and 1, but we're kind of taking over the responsibility of giving them names, and we're saying, well, Xcode, you don't give me the greatest names for these. So instead, now we get aisle and name, and it feels a little bit more natural and readable. So I'm like, oh yeah, I'm printing out the caret's name, as opposed to I'm printing out whatever this 0 thing in the tuple is, and then I'd have to kind of look back up here, and it just becomes kind of a whole pain here. The cool part about tuples here is we can add as many values as we want. So we could have just 2, or you could say, I want to add maybe a quantity as well. So we have like 25 carets or something, and that's valid. And you could keep going in theory as long as you wanted with different values within the tuple itself. That's really all there is to a tuple. There isn't like much kind of going on with it. But I had a student in my morning class ask me, or like before we went over tuples, well, what if you wanted to return multiple things in a function? We talked about tuples, and you could do that where, don't change this, but just watch me here. But you could say, maybe I want to return an integer and a string saying, the average is, and then you give it the average or something. So that would be a way of returning multiple things within a function if you wanted to go about that. There are definitely better ways of doing this, and again, like I said, we'll be talking about those on Monday, but that will kind of give us a starting point. So you'll end up using tuples in your module project and essentially everything we've talked about today. So that's why I wanted to make sure that we get to these, even if we do stay a little bit later. So
Spencer, I got a question about those tuples.
Yes, go for it.
Sorry, I think someone spoke. Well, was there someone else that, whatever, so I think for the project on the knock list, it asks us to use a tuple. I just kind of wanted to clarify exactly, yeah, it's like step to end or something. I don't know. One of the steps was going over a tuple, and I just wanted to kind of understand it, like how are they useful as opposed to maybe like an array function or anything like that. I mean, what makes them so useful?
Yeah. Well, let's actually take a look at the knocklist project, and we can kind of look at what you're talking about here.
I remember reading about it.
No, you're great. This is a great way to kind of segue into tomorrow's project for you all. Definitely read through these instructions here. It kind of gives you an overall view of what the app is going to do, and it's kind of themed like this is like a Mission Impossible style thing. So this is going to be your tuple that you make. So you've got a cover name and a string, a real name and a string, an access level and an integer, and then this compromised and false here. So it's going to let you combine all of like the information about one single person into a tuple, so you kind of keep those all together. Is that kind of what you were asking or not?
Yeah, because when I was looking at this, I was going to be like, okay, let cover name, and then I guess create an array function for each one, and then let real name.
Right.
So this, I mean, I create less with an array function. That's why I kind of asking, because I can do let cover name, let real name, let access level, and let compromise in an array versus creating 1, 2, 3, 4, 5. Looks like, it could be a bunch of them in a tuple. So I think the tuple is cleaner, but I just was wondering.
For sure, than having a bunch of arrays. What you could do is kind of go on and say like, let, I'm just going to do it in the case of like these shopping items, but you could do the same thing for your agents. You could say like, let shopping items equal, and then you could have an array of your tuple here, right? So you could have like carrots, and you could have potatoes and steak or whatever you want. And so then you could have an array of all of those cover agents in just one single array as opposed to multiple, if that makes sense.
Yeah, that does. And then you would create a tuple off of your arrays is what I'm guessing that you're kind of getting at.
Well, you'd already have those tuples, and those would be the individual items inside of that bigger array.
Oh, okay, got it. All right, cool.
So that's
yeah.
the container.
Same thing. Yeah, same thing. I was kind of saying. I was thinking.
Yeah. So, great question. Are there any other questions about anything that we've got here with tuples, or anything else that you guys want to bring up before I let you go?
When is the knocklist project going to be due?
Great question. I don't actually know as far as part-time goes. I would assume at the end of the day tomorrow, but I could be wrong. Hector?
Okay. Yeah, it should be due by the before next lecture. So the next guided project would be on Thursday.
Okay.
Yeah, so then it'll be due before we start class. Does that make sense?
Before Thursday?
So the guided project is always due before the next guided lecture. I'm sorry.
And that's Thursday.
Yeah, that's
so
Thursday.
you've essentially got like 48 hours from now to work on it.
Exactly.
Okay, cool.
Great question. Sorry about that. That's more of a TL thing. Any other questions?
So can you loop through tuples?
You can loop through an array of tuples.
Oh, okay. Just not the tuples themselves, like the loop through. Yeah.
I don't think so. But keep that in mind, looping through an array of tuples, because you might need to do that in your project. Any other questions before I let you all go?
I have one question. It's unrelated to today's lesson, but on the calendar it says something about TL support hours. What are those?
Yeah, those are essentially like the after hours that I talked about yesterday. I think those are more geared towards if anyone is struggling in class and they need a little bit of extra time. TLs, do you want to chime in on that and just correct me if I'm wrong about that or anything? Or just...
Support hours?
Yeah.
Yeah, that's just basically, for when, if you need help or you're stuck on anything, you can basically, we're available and can help you get unstuck or help you with whatever you're needing help with.
Okay, cool. Thank you.
Yeah, supplementary time outside of like the normal you know, hours that we have. Ivan, do you have a question? I just saw that you raised your hand. Oh, or is that a clap? I can't tell.
No, I don't have any. By mistake.
Oh, no worries at all. Okay, I think we'll call it good there. If no one has any last questions, final chance. Okay, killer. So as far as tomorrow goes, your schedule is just going to be, you'll be coming to class. The TLs are going to walk you through the exact schedule, but it'll just be a time for you to be working on this project, and the TLs will be available to answer any questions you have. I'm sure I'll probably just be around on Slack, so I might be answering some questions as well. So have a great project, and we'll talk to you guys later. Thank you guys so much.
Thank you.
See ya.
Thank you, Spencer.